Hello and welcome to Relatable Code. In this video, we're going to talk about coroutine jobs in Kotlin. So let's get started. When dealing with Kotlin coroutines, a job is a foundational concept that represents the execution of a coroutine. It's essentially a handle or reference to the coroutine's lifecycle, providing critical capabilities to manage its execution. A job allows developers to control the coroutine by supporting operations like cancellation, for example, which makes it a cornerstone of Kotlin's structured concurrency model. The life cycle of a coroutine is tied to its job from the moment a coroutine is launched until it completes, fails, or is cancelled. The job object is responsible for tracking its state. Okay, and this lifecycle management is crucial for ensuring that resources are properly allocated and released as well. We need to make sure that coroutines behave predictably within the application's broader execution context. When a coroutine is launched within a scope, it's automatically associated with a job object. And this association is very important because it ties the coroutine's execution to the life cycle of the scope that it's launched from. Okay, for example, canceling the job of a coroutine scope effectively cancels all of the coroutines which are launched within that scope, which demonstrates the hierarchy nature of coroutine cancellation and lifecycle management as well. Jobs play an important role in Kotlin's structured concurrency concept, which aims to simplify concurrent programming by ensuring that all of the operations are scoped and controlled as well. Structured concurrency ensures that coroutines are not left running indefinitely, which leaks resources in return, by tying the coroutine life cycles to application structure, such as activities or fragments in Android. Jobs facilitate proper error handling and resource management in asynchronous programming. By attaching a coroutine to a job, developers can catch exceptions thrown by coroutines and handle them in a unified manner. Also, resource management is efficient, as the job can help ensure that resources are freed up when a coroutine completes or is cancelled for any reason, which prevents leaks from happening. You will find out that jobs are important in many different scenarios, and one of those scenarios are managing long-running tasks. Okay, because jobs allow for cancellation of long-running operations, such as maybe data processing or computation, that may need to be stopped if the user navigates away from a UI screen, or if the operation is no longer needed. Jobs are also used with user-initiated actions. Okay, when a user interacts with an application, like for example, clicking a button to fetch data, jobs control the execution of these actions, allowing them to be cancelled if the user decides to cancel the operation or navigate away from that screen. Okay, and you will also use jobs with network requests and applications that perform network operations. Jobs ensure that requests can be cancelled if they are no longer needed, which will optimize network resource usage and improve the responsiveness of applications. Okay, and in addition to that, you can also use jobs to handle UI updates for operations that need to update the UI based on some data that you're getting from the backend server, for example. Jobs can ensure that these updates are only performed if the UI component is still active, okay, which will prevent exceptions and improve user experience as well. In one of our previous videos, we used this example of a countdown timer manager. Okay, and we created it inside our main activity so that we can use it with a text view and a button. I'm going to run the application so that you can see how it works again. This is our emulator. And as you can see, you have this text view with seconds left, starting at 60. as you can see right there. And with each passing second, it will get decremented. Okay, and if you click on stop timer, this timer will basically stop. Okay, and what we're doing here is we're using this countdown timer manager class. Okay, I'm going to go over the details of this class. In that video, we only explained about the importance of coroutine scopes. But in this video, we're going to dive into jobs. Okay, so inside this class, we're creating a job. We're naming it timer job, and it's initialized to null. Okay, and after that, we're defining a scope for this job. And this scope will be a coroutine scope with a dispatchers.main. And we're using dispatchers.main because the updates that will happen inside our function need to be reflected in our UI. Okay, they need to be reflected directly, which is why there's no need to use another dispatcher. Okay, we only need that UI thread. And inside this function for start timer, it's taking the duration as a parameter. As I've showed you inside the main activity, we're passing 60 as the number of seconds to be used inside this timer. And we have an onUpdate lambda. Okay, this onUpdate lambda will broadcast the new update to the duration to the main activity. As you can see right there, when you open that lambda block, you get this it right there. Okay, and this it is the remaining duration. So as this is being updated, you're going to need to update the text of your text view timer, this one right there, with seconds left and the total number of seconds left, okay, which you're getting from this function right there. Because when you go inside this function, the first thing it's going to do is if there is a job being run currently, it cancels that job to make sure that it starts fresh. And this is very important when dealing with jobs and coroutines. Okay, before starting any job, you need to make sure that it's not already running. Okay, so you need to cancel it and then relaunch it, just like that. Okay, which will reinitialize timer job to be timer scope dot launch. Okay, if you hover over timer job right there, you can see that this is still a job which is being launched within this scope. Okay, and inside this job, we're creating a variable to track the duration in seconds which are remaining. Okay, and after that, we're having this check being performed. Okay, this is basically checking if the remaining time is greater than or equal to 0, because we don't want our countdown timer to be less than 0 at any instance. We want it to go down to 0. Okay, that's why we used this as a first check, and with respect to the second check, it is active. Okay, and this is something related to the coroutine, which just helps you make sure that this coroutine is still active and is not cancelled. Okay, because when you cancel the timer, as we've done right there, as you can see, this is no longer getting updated. Okay, because when you cancel that job, this Boolean variable will automatically be set to false. Okay, it is not active anymore as a result. And this code will no longer get executed. Okay, but when this coroutine is still running, what happens is this lambda is getting invoked to our main activity with the remaining number of seconds. Okay, and after that, a delay is happening for 1 second, and after that delay, we're decrementing the remaining time. Okay, remaining time will be initialized to 60, and when you go inside this function, you will check this code right there. You will reach this stage. The onUpdate will broadcast the remaining time to the UI, which will start at 60. And after that, it will start creating these delays. Okay, it will be first 60, then 1 second will pass as a result of this delay function right there. And after that, remaining time will decrement. And this while statement will continue to execute. Okay, because both of these conditions are still true. After that, the onUpdate will broadcast the new remaining time, which is now 59, before waiting another second and decrementing the remaining time. Okay, that's how our countdown timer is currently working, and that's pretty much it for the setup. Okay, that's all there is to it. You broadcast the remaining time to the UI to update the text view. After that, you wait for another second before decrementing it. After that, you process the change again. You expose it to the UI so that it becomes 59. And then you wait another second before you go through this process again. Okay, that's how our countdown timer is working. And you really need to pay attention to the is active right there. Okay, because when you cancel this timer job, is active will be set to false. So you need that just to keep track of this coroutine, whether it's cancelled or not. Okay. Imagine you're developing a social media dashboard application that displays various types of information simultaneously, such as the user's profile, the latest posts, and the friend's activity, for example. Each of these data types is fetched from a different network request and independently. In this setup, you can see that I have a dashboard view model and a function. Okay, inside this function, we're launching the view model scope, and inside that scope, we have a try-catch statement. Okay, here we're trying to launch 3 operations in parallel and collect their results as well. Okay, these are the operations. We have load user profile, which returns a string, just like this function as well, to retrieve the latest posts of the user, which delays for 1 second before returning a string, and similarly with the friend activity, okay, which delays for 2 seconds before returning friend activity as a string. So these 3 operations are launched in parallel like that. As you can see, they are launched inside this coroutine scope. And here we're calling await dot also to log the result of that operation. Okay, so if you run your emulator again, you will have the full source code of this setup in the video description. Open your logs and filter for data output. Okay. Check your emulator and click on fetch data, just like that. And here, as you can see, these data are fetched one after another, and they are launched in parallel. Okay, so this one is fetched, followed by this one, and followed by this one as well. And that's great. But what if the second function returned an exception for some reason? Which may happen, especially with network requests. So let's simulate that with a throw, not a Java lang exception, a normal Kotlin exception. Error occurred while retrieving latest posts. Let's comment out that line for now and rerun our application. Okay, open your logs again, clear them, and now click on fetch data. It will fetch just the profile, and as it is fetching latest posts, it will get an exception. Okay, and as a result of that exception, an error has happened with this coroutine, which will suspend this whole job from executing. Okay, so as soon as an error or a cancellation happens with an operation inside this coroutine scope, the whole coroutine scope will get cancelled. Okay, and that's how you can ensure structured concurrency in Kotlin, because as soon as one operation fails, it will definitely terminate all of the other operations. Okay, so that other errors can not occur in that case. Well, what if these three are independent operations, such as our case, and we don't want the failure of one operation to affect the other operations? In this case, we will need something called a supervisor job in Kotlin. A supervisor job is a type of job that changes the default propagation of the cancellation and the failure in case of coroutines. Okay, unlike a regular job which cancels all of the children if one child fails, a supervisor job allows its children to fail independently without affecting each other. Okay, supervisor job comes into play to solve this problem. It allows coroutines within the same scope to operate independently in terms of failure and cancellation as well. So if one coroutine fails or gets cancelled for any reason, it doesn't affect the others. And you can easily create a supervisor job here by substituting coroutine scope for supervisor scope. Okay, it's that easy. But one thing you also have to do right here is you have to wrap each and every one of these three await operations inside try-catch blocks. Okay, so that when one of them fails, it doesn't affect the other operations. So let's go ahead and do that. You can use Control-Alt-L for the shortcut to get this try-catch statement. And here we're going to wrap each one of those inside try-catch statements. Okay, so you can do the same for this line of code, just like that, and this line of code as well. Let's wrap that inside a try-catch statement. Where is it? Did something happen? Control-Alt-L. It doesn't seem to appear. I'm not sure why. Let's just write it manually. Just like that. And for this one as well. Okay, so you need to have try-catch statements for each await operation so that if one await operation fails, it is handled like that, and the rest of the operations can proceed as well. Okay, so after you do that, go ahead and run your application again. That's your emulator. Open your logs, clear that log. We still have that exception here, which is what we want. And get back to your emulator and click on fetch data. Okay, so here you have, as you can see, you fetched the profile. You tried to fetch the latest posts, but you couldn't. So you also fetched friend activity. Okay, so this exception didn't prevent you from fetching this data as well. And that happened thanks to the supervisor scope right there. Okay, you need to make sure that the supervisor scope is also wrapped inside a try-catch statement, and that each one of these await operations, not the async operations, you need to wrap the await operations inside try-catch blocks. Okay, so that these coroutines can handle the errors effectively without blocking the whole thread or even terminating the application. Okay. If you like my type of content and you find it to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.